Good afternoon. Just as a reminder, this talk is going to be in English because I prepared for your Python, so it's in the poster, but whatever. I'm a linguist, a computational linguist. Um, I know a lot of things in machine learning. I are based on the algorithms and on the machine learning itself. But my job is to increase the accuracy and the precision up to almost the 100%, which is not possible usually with the algorithms. So my job is to manually somehow improve the numbers. And my talk is about that, about how to improve those exceptions of the language, which are always present no matter the language. So recipe, oh, it's gone. Recipe for text analysis in social media. Hello there. Ah, no. Okay, thank you. So this is a recipe for text analysis in social media, and I'm going to speak about the linguistic approach. In order to analyze social media, you will find a lot of different texts and a lot of different formats. So the most important thing you want to do first is to decide how to approach your problem. So first you want corpus, which in our case will be the social media text. Then we are going to pre-process the text. I'm gonna talk about strategies and problems you'll find and how to fix them. Also, I'm going to show you real world applications. Then you could go with the text modeling, which is what I don't do. But basically, you will need to know how to define the purpose and which kind of classifier you're going to use. And with these ideas, you get to do the pre-processing so that then the text modeling is better, and then you get the results. So what's social media? Social media is whatever kind of web application that has users and profiles and also interaction with real news. And people are usually able to comment and provide their opinion. So you'll find really different types of social media applications. You'll have the most frequent ones like Twitter and Facebook, but also you have the Amazon reviews and booking reviews, TripAdvisor, and also you can use data from the Wikipedia. Once you have your data, I'm going to show you later how to extract the data in a really fast way, but the kind of contents you find are usually text, images, and videos. And out of there, you need to decide which ones are you going to use. Once you've got that, you can start with the basic steps for text analysis, as I said before. And you first want to gather the corpus. You can find basically two main resources, which are online free corpora and web scraping. For online free corpora, I like this one very much. This is a video. Okay. So if you download NLTK, you can. This is not working. So you can download NLTK with all the packages. And it's very useful when you start doing language processing because it has really good corpora you can use. It's labeled, it's organized, and it has a lot of different topics. So you can explore the corpora, and it's easily downloadable from the web. As you can see here, you can decide which ones you want to download and which ones not. And it's a huge corpora, so it's a lot of data. But it's very useful if you want to start using these. Also, you can find the BWY corpora, which is really very useful. It's in English because in Spanish it's difficult to find good databases. But they also have something in Spanish, which is, I think it's worth to have a look at that. And also the British National Corpus, which is also in English. And well, you can find a lot of resources. The next thing you can do is to web scrap the data. Basically, you can web scrap whatever you want, but if you want to analyze social media, you can use websites such as Meneame, which are really good. Also, Twitter is very common, but as I'll tell you later, you'll have a lot of problems with Twitter by analyzing the language. So it's worth a try, but you need to take that into account. In Meneame, you have the news, and you also have comments, you have tags, which are useful for classifiers and train algorithms to topic discovery. And also you have posts about a lot of topics, and also they are separated in topics, which are very useful, as you can see here. And in Twitter, you have hashtags and tweets. And within the language, you have also the mentions, which I think are worth also taking into account if you want to find name entities or this kind of language. So when it comes to preprocessing, which is what I do mostly, you need to take into account what are your aims, what is your aim and your objective, because depending on what you are going to do, you need to organize your data in a way or another. So tokenization is very important. Tokenization is, I don't know if you, well, I don't know if you know the word, but tokenization is splitting the text into units or elements. So you need to define what an element or a unit is for you. Because you can say, okay, I'm going to split by spaces. Yes, well, it's okay. But if you want to find name entities, for instance, that's not the best approach at all. Because you will have something like City of Bombay, which you might want to keep together, or Dr. Narliker's nursing home, which is also a name entity, and you might want to keep it as such. And also dates as August 15th. So you need to think about that before you start, because otherwise you'll have problems once you have the data processed. So also the language is very important, because Chinese and Japanese, for instance, among other languages, are agglutination languages, and they don't use spaces between words. So it's kind of difficult to use the spaces as a separator. Don't have them. Also, Japanese has different alphabets, which is also not good for you if you want to split the language easily. So as an example, because I know this is theory, but as an example, I took a corpus from the NLTK package, and I processed the text, and I took a list. As you can see here, is a list of words, but you can see that, for instance, Pierre Vinken or November 29 or Mr. Vinken, you might want to keep those as one unit and not different units. Also Rudolf Agnew and so on and so forth. So here, with this little tiny amount of code and regex, I know people don't like regex, but I do. So only with these lines, you can improve the text much better, because you only need the regular expression. This is a very simple one. You can, I mean, you can add a lot of different things here, but this is a very simple one, and you can use this regular expression plus only the regexp tokenizer in NLTK, and and you come with this, which is very easy and very useful if you want to find name entities. Also, we could improve it by grouping 61 years old or 55 years old, or, oh, sorry, it moved, but it should be November 29. But it's very useful and it's very simple to do, so it's a very good solution. Also, we can use word stop removal. This is the list I used. Well, you don't need to read it. It's just words that are non-lexical words, which is pronouns and determiners. Also, you can use, for instance, text markers. I mean, you can add wherever you want in the list. This is up to you. And here you can see the difference. The first section, you can see that the initial corpus had more than 94,000 words. With the regex, we kept corpus with 77,000, and with the stop words removal, we ended up with 46, which is very useful if you are going to analyze, in this case, for instance, name entities, because my aim in this case was to find name entities for then the sentiment analysis. So you need to identify the entity and then being able to use the entities to find the sentiment. Also, you can do lemmatization and stemming. This is not very difficult. It usually goes with a dictionary. You will have a dictionary with the full forms and a dictionary with the inflectional forms. Inflectional forms are, in Spanish is easy. All the verbs, all the endings are inflectional forms. And if you want to keep the original full form, is the infinitive form. So basically what you want to do is to group all verbs into a single form and not having all the forms as different words, because they all have the same meaning, no matter no matter the person. Stemming is also easy because you only chop off the ending and you don't get the full word, the full infinitive word. You only get something similar, but also it's useful to group entities. What are the problems? Basically, in social media, the problem is time sensitivity. Because language is dynamic, it changes all the time. You can never expect to fulfill your idea of having something finished, because you can do a task or you can create a script for web scraping, but anyway, you will get problems with that because the next day it won't work anymore. So you need to keep going and create something dynamic for dynamic language. It happens in blogs, in microblogs, and social networks. I mean, it's really time-consuming trying to cover everything. So there's a problem. Also, short length, for instance, in Twitter is really straightforward. You have a limitation of characters, and people don't tell the whole thing. So you need, sometimes you don't have context. Sometimes you don't know what the person is talking about. So you need to relate somehow one idea to another without a real context. So it's also a problem. Also, you have unstructured data. Basically, you can see that misspellings are a problem. I don't know if you know about this, but you usually will use a MET algorithm, which is minimum edit distance, and you will try to do something similar as they said before, that you need to somehow find a pattern similar to something you already have, and it's more or less the same. It's also used for DNA chains and all these kind of problems. And well, this is the problems you have. Also, words like should be separated or together, and they are written in a non-canonical way. So, and finally, you have abundant information. You have tons and tons of data, so you need to decide what to use because you cannot cover everything, as I said before, and it's a problem. Applications in real world are a lot. I mean, you can decide, for instance, if news are popular, if a topic will be popular. You can detect events. For instance, people start tweeting about something, and then you can discover this new event. Also, you can take advantage of collaborative QA, which is pages such as Stack Overflow. You can retrieve information from Stack Overflow, and you will know that many information will be useful, many will not, but it's also worth a try. Also, you can use information in the web to to cover for those contexts you didn't have before. When I told you about tweets and the problem of context, you can use social media to try to cover for this context, which is also useful. Well, also it's useful for sentiment analysis, as I said, and also it can be used to identify influencers and people who are famous, or ideas that are famous, and well, and also for Amazon reviews, it's useful to decide how faithful a comment or a user can be. Like, you know that this user is faithful, so if they post something, you know this is true, you know you can trust them, and you can take that for granted. Or at least it's an opinion which is useful to have a look at. Then we go to text modeling. As I said before, I don't do that. But basically, what you need to have is what is your aim. So you have to define the task. And in my case, I wanted to identify name entities and then decide whether they had positive or negative reviews. So once you have the entity, you need to classify the reviews into good or bad. I didn't use a really complex system. It's very straightforward. There's two main strategies. There's the supervised and unsupervised learning. Supervised learning, I usually do that because I need a really high accuracy and high precision. So I use dictionaries, I use regular expressions, I use rules, I use grammars. So you have a labeled corpora, you have examples, you have predefined categories, and you usually work with sentiment lexicons because they are labeled. And if you want to do unsupervised learning, you would try to do topic discovery, you will try to use algorithms to decide what to do, and then my part is to run the training after this is, I mean, after the unsupervised learning has reached their top, I have to do supervised learning in order to improve this. So a very basic algorithm for sentiment analysis will use only two. You only need two things. I don't know if you can see that. You need positive vocabulary and negative and neutral vocabulary. So this is one ingredient. The other ingredient is the list of comments you want to analyze. Then you run a really simple search, and you'll get the result, which can be positive or negative. This is it. I mean, you don't need anything else, and it's very basic code and very short. So the simplest lexicons are represented in a binary fashion. You can download a lot of lexicons which are already in the web, so you don't need to do this. It's a really tough work, a lot of work. And here you have many lexicons that are available online. They're mainly in English, as I said before, but for WordNet, you have the Spanish also. So it's very useful. WordNet has a package for NLTK, so you can download the package and use it, and it's really good. And if you want to do unsupervised learning, there's this article about these two guys, I cannot pronounce the name. And they decided to investigate that, and they came up with a very good idea, which is the polarity lexicons, but they are automatically or semi-automatically created. And it goes like this. You have words in a text, and you find coordination, as in and, or disjunction, as in but. If you have words joined by coordination, you will consider them to be in the same block. Like, for instance, in this case, simple and well-received, it will consider to be in the same block. In this case, it could be positive. But if you have simplistic but well-received, you will consider them contrary words. So you will put one in one group and the other one in the next group. And somehow you can group the words together in different groups more or less automatically. You will need a very small lexicon to start with because you need something to compare your text to. So you will need a small amount of positive words and a small amount of negative words so that the algorithm can assimilate words to one group or the other. But it goes like this, and it's very good. It's from 1997. I know it's old, but it's one of the ideas that it's working until, it's been working all these years, and it's a very good idea nowadays also. And well, if you did your job well, you will get the results and whatever. I like to work with supervised algorithms because I think it's better if you want to achieve high accuracy and high precision. I know machine learning is not onto that, but linguistics is not that easy, and language is very difficult to organize in a way that is clear for data analysis. So I think the more you want to improve and the more you want to do it really well, you need somehow to work with supervised data. It's up to you, of course, but in my opinion, it works pretty well. So here I have some useful links. Also, I recommend the third one, the speech and language processing by Dan Jurafsky. This is a guy from the Stanford University. They're really, really, really good. They published their first book many years ago, like 15 or 20 years ago, and it's still one of the fashionable ones. They're really good, and it's very well explained, both for linguists and for programmers, because in a way it helps you understand the other side very well. So I recommend that. And also mining text data. It's a group of articles which are worth reading. It's in text format, sorry, book format, but they are collecting articles, and they are really useful. So I recommend that. And well, about me, I'm a linguist. I am not a programmer, and as I said before, my job is not to program, it's to improve what programming can do. So yeah, I don't do data analysis like the hard way, but I think our job is also really, really useful, and I like it very much. So you know something about me more now. And well, this is it. It's here you can find me, and you can ask me any questions if you want. So I hope you enjoyed the presentation and you understand the English version of it. So thank you very much.